We're going to go ahead and get started. We're already a few minutes past the hour, so I'll let you catch up when you're filtering in. My name is Kate Petersen Mace. I'm with ESNet. I'll be chairing this session. So this session, as you'll see from the program, is actually fairly short. It's 30 minutes. And we have four very talented panelists. And so think of this as they're each going to have just a few minutes to talk about what they're doing in their work. And we're focusing on international scale measurement technologies and techniques, and various things that they've done in their on their NRENs or in their networks in general, and some of their work. And so I am going to turn this over to the panelists. You can kind of think of this almost as a lightning talk, if you want to say, since this is a condensed panel. And so I've asked them to kind of talk about some of the work they've done, and then I encourage you to actually talk with them afterwards in the break if you'd like more information, and we'll see if we have a little bit of time for Q&A afterwards. But with that, I will turn it over. Let me introduce you, actually. Sorry, this is Jen Schopf from Indiana University, and then we'll let them introduce themselves in the interest of time.
Hi. So just before the break, I was talking about our new project, EPIC, which does end-to-end user support. And I hinted at the fact that this is really driven by the needs for measurement and monitoring, right? So the measurement and monitoring infrastructure we use is called NetSage. It's called NetSage. NetSage is a joint project with LBL and University of Hawaii, and it was funded through the NSF International Networks program to understand the use of the international networks. We've got a portal. I'm going to walk through a scenario as if I were the end user, because actually in this case, we were the end user. My team also runs links between the US and Europe and US and Asia. I've got a big monitor in my office, and we've got the NetSage portal up there every morning, and it came in one morning. This is what a normal top of the screen looks like. It's got a map, and it's got the links there, and they're different colors depending on how much they're used, but you know, these are links have a lot of capacity, not too much traffic. So came in one day and there was a big red line between the US and Europe, which turns out it's actually good. That means there's a lot more traffic than normal. I was like, okay, well, that's a bit odd. What's going on here? You know, maybe somebody's running some tests. Maybe there's an experiment. No one's mentioned anything to me. So we looked farther down the page and I actually asked it to show me the last 5 days of data. This is part of the portal. You can set a time frame on it. And it says, okay, you know, so the 5th was a Monday. Somewhere Thursday night, Friday morning, something happened on this link. Whole lot more traffic than it had been before that. And I'm looking at it, and it doesn't look like test traffic, because most test traffic has a very square shape. And if you look at these two bar graphs, those are the sizes of the messages, and those are all over. And test traffic's usually a lot of small messages or a lot of big messages. So I said, okay, well, this is weird. You know, are the other links seeing this? Nope, this is everybody up here, and they're not seeing that too. So NetSage was working on a prototype looking at flow data, de-identified flow data that it picks up from the routers, okay? So it goes down to the level of the organization, but not further. They said, well, let's look and see what's been going on, you know, what are the top talkers by the volume of data over the last 5 days in this link? And I got this list of applications, or this list of end sites, and the current version's got a better layout, but you know, I'm looking at this going, this is an unusual set. We've been tracking the top talkers for this link for a while. This is a lot of DOE traffic. This is a lot of energy sciences, high energy physics traffic. You got Atlas guys, you got CMS guys. What is going on with this? Usually they're not on our link. And we're like, well, you know, let's go and see if something's happened with some of the transatlantic links that ESNet supports. And as we're digging into things, we get an email from our colleagues at ESNet saying, hey, you know how we've been talking about setting up that VLAN to put some of our traffic on your link? We got it up and running on Friday, which explains what had happened with that traffic. So this is one way people use the NetSage portal. It was set up to understand how are the links used? How are these international government-funded links used, because every other large-scale facility that NSF supports has this data readily available. We're currently doing a release of the flow data, so we're able to show you by organization or country or a couple other options by either the volume, so how much data over a time period, or the rate, which is the fastest or the slowest, you know, what's going on in your links, both as a top 10 list and as a paired list. Within the EPIC project, NetSage is going to be the underpinning for our measurement monitoring approach. That initial dashboard uses SNMP and perf sonar data. We're starting with that with our regional partners, starting off with GPN back here. Wave your hand. Thank you. In part because we use a Grafana analysis framework, which lets us do extremely flexible queries and analysis on this. And part of what we want to try to understand is what are the soft failures? Measurement and engagement are two sides of a coin, as I mentioned just before break. This is Harper Reid. He was CTO for Obama. This is what they lived by. If there isn't a metric, it doesn't exist. This morning, Inder said, if you can't measure it, you can't improve it. That's what we believe. So, takeaways from this, from my brief lightning talk, and I am within time. NetSage is a tool that's out there, currently being used. It was prototyped internationally. We're now doing domestic deployments, and it's going to be a fundamental underpinning to the Epic Center. If you want more information, here are some pointers. Thank you.
Thank you, Jen. Next, we have Dima from UCSD. I'll let him introduce himself, and I will advance the slides for you.
I'm Dima Mishin. I'm working for UCSD, SDSC and KLIT2. And I wanted to talk about the tool we developed. Can I have the slide?
But it looks like, sorry, Kisti was next. So let me, there we go.
Yeah, thank you. So the state of the art for measurements is PerfSonar, of course, but if you think about it a little more, it has more information that it shows in MatDash. PerfSonar is collecting trace routes and then throughput, packet loss, latency, stuff like that. But those measurements are not connected to each other. And if we get trace routes, database of trace routes between all the points, then we can build a graph of the whole network with all the routers on the way. And on that graph, we can plot the measurements for point to point, because in MatDash, you only see endpoint to endpoint. So this whole link is bad, but you don't know where exactly. So if we overlay this information for point-to-point on the graph we get from trace routes, and for each segment we choose the best performance. So for each segment, we will, if we have enough points, for each segment we will have several measurements. Some of them will be good, some of them will be bad. And we choose the best measurement for each segment, and for some of them we will only have bad measurements. And so those will be segments where we have the problem, probably. Can I have the next slide, please? So this is a trace route tool I've built. This is working in JavaScript, so it's just a web page which lays out this graph. And so it works well. It shows bad segments, but we really need to have enough nodes so that we have enough measurements. And in terms of international, so for now we have only one node in Korea, which is outside US. Most nodes are in California, some are in other states. And so once we have more nodes internationally, we will be able to also detect problems outside of the border. That's it. Thank you. Just 2 slides.
Thank you. And next we have Wontaek Hong from Kisti.
Okay. Hello everyone, I'm Wontaek Hong from Kisti. Today I'll talk about Kisti Science DMG project and examples on behalf of Jeonghoon Moon. Regarding Kisti Science DMG project, I will explain what we are doing with Science DMG until now and give an introduction to areas in which our research network CREONet can support or coordinate in the near future. I also introduce our efforts to participate in global 100 bits per sec DTN joint demonstration in SC. Next. Yeah. In this slide, I will explain the status of Kisti Science DMG environment. We have 2 types of DTN. One is the SDN-based DTN environment. The other one is a layer 3-based DTN. Based on this environment, we have participated in first PRP workshop and first NRP workshop. As for domestic deployment, we have a focus on data-intensive science areas. For example, there are K-genome, genome RDC, LSS project, and so on, as shown in right and bottom picture. Especially EKVN and LSST project in KASI, Korea Astronomy and Space Science Institute, support 100 gigabps environment. Recently, KIST has deployed a new supercomputer and been preparing for working with DTN cluster on 100 gigabps network environment. As for another example application, dark matter research using astronomical particle big data will be performed on Science DMG environment. Regarding international collaboration, we have participated in PRP and RP project and will join a petascale DTM project with the collaboration of ESNet and NERSC. Additionally, in order to coordinate Asia PRP communities, we have a future plan of Asia 100 gigabps interconnection with Australia and Singapore. It means Science DMD expansion to Asia potentially, and the collaboration of global 100 gigabps partners in Asia. Next. This table shows major applications that have been supported by CREONET. Many of those institutes are member institute of CREONET, so therefore it is possible to have a close collaboration with them. In the near future, Science DMG environment will be implemented in many of those institutes and utilized for their own research. My last slide, in this slide, I will introduce our plan for SEC demo and LSST project in Korea. We will perform 100 gigabps DTN demo between SC KIST booth and Daejeon in Korea. In order to do so, 100 BPS switch and DTN will be set up at booth. As for PRP and APRP collaboration, we will participate in various demonstrations and organize some community workshop. Regarding the collaboration with the global partners, we plan to participate in global 100 bit per sec DTN demo led by Caltech's Harbin Newman team. Especially as for 100 bit per second LSST demo, we focus on real LSS data from Chile to real users of Korea via US, as shown bottom picture. KASI is one of CREONET 100 gigabps users and one of the international contributors on behalf of LSST Korea communities. So KASI will join and contribute this demo. Two endpoints which are located in KASI and KIST in Daejeon will be available. 100 BPS DTN will be set up before SC. Until now, we have been discussing how LSS data will be transferred to Korea and working on a real scenario with other partners. Yeah, that's all. Thank you.
Thank you. Next, we have Lars Fisher from NordGNet.
Oh, let me get this one over here. So rather than walk you through a single tool, I decided to spend the 5 minutes I have to walk you through some examples of things we try to monitor or problems we try to address. If you want to know more about the individual tools, you'll have to come to me in the break or have it during the Q&A. We can go into depth with some of those tools. So NordGNet is essentially a global network operator. We do other things, but the main core of our business is to operate a global network. It might seem strange since we're supposed to serve the Scandinavian countries, but it turns out that our users require us to provide end-to-end service for many things they need. So for example, for major cloud providers based in the US, we've been asked by our users to provide the end-to-end capacity right from whatever Swedish university right to Amazon or whatever it is in the US, if that's what they're using, or smaller cloud providers like Box or whatever. We have institutions that have Chinese campuses, and again, they like us to have a network all the way to where that site is. So we have POPs in Hong Kong, we have POPs all over the US and things like that. And we want to, I mean, as a regular network operator, we like to have all the operational statistics, all the day-to-day monitoring stuff that Jen was talking about. So that's one area we need to address. We need to be able to have all that statistics that allow us to gather the information about the traffic, that allow us to do the planning, that allow us to talk to our users, to allow us to understand what the outage is, all the usual stuff you need there. It also turns out that one of the things we do that is maybe different from what many American networks do, but it's quite common in Europe, is that we are not just an academic traffic network, we also do commercial upstream for our campuses. So for most campuses, we are their single upstream, so we run lots and lots of traffic from them towards Google, towards Amazon, towards the Microsoft, whatever sites they go to, YouTube. So we have thousands of peers, right? And managing a set of peers and understanding which aggregators you want to run through or which ones you want to peer with directly, you really, really need tools to look in depth in your traffic flows. It turns out also for big science flows, you also want to know historically which flows are you having, how the flow patterns changing. So we are more and more looking not just at operational statistics tools, but also an operational flow analytics tools that allow us to understand what the flows are so we can decide where to traffic engineer and where to peer with whom. So we need tools for that. And then we've discovered that there are very interesting things going on with routing, much more than we thought. So routing changes more frequently than we thought it would. We have done tools that analyze what we call microdependencies and very short-term changes. And we have been feeding changes in our BGP mix and in observations we've done on micro changes in traffic into things like elastic stretch and done very fine-grained analysis of how the routing behaves. We learned a lot about our routing. We're trying the same exercise on other people's network. We learned a lot about their routing that they didn't know what was going on. We have experimental tools for that. And we are handcrafting some of this with Elasticsearch and so on. And we are now operationalizing some of those tools and trying to integrate them with Persona. So watch this space. But it's very, very interesting. You can learn much more about your routing. There's much more going on than probably most of you think is in ERP networks. So those are also things we're doing. Next one, please. And then another thing we're doing is that for transoceanic traffic, it turns out that for network our size, getting the required 300 to 400 gigs across the North Atlantic is just more than we can afford. So we decided to team up with other networks like us, in this case, the NEAR project, ESNet Internet 2, Canary, SurfNet, Xiang. We have a collection of links here. Here are some of those links. So this is a system of links that we treat as if it's our personal 3 times 100 gig network across the North Atlantic, but it isn't really my private network. It's a network I share, or a component of a network, a system I share with 5 other major networks. And so I can't just measure that as my own. Of course, I can measure my own traffic, but I also need to understand how the traffics of other networks and the dynamics of those behaviors are impacting my network. So we need to come up with ways of measuring a complete shared system. And we think that globally, more and more things like that. We are currently working with a similar setup with some Asian networks. So we will do a shared network with a couple of links towards a couple of 100 gigs links between Europe and Asia. And again, we need to find ways, and this is sort of bleeding edge of what we're working at the moment. We need to find ways where we can measure, monitor, instrument shared infrastructures that are not owned by a single operator and do that in a way that is useful for all the partners in that shared infrastructure. So that's what I have.
Thank you, Lars. Well, I have to say, the panelists did an excellent job of staying on time, actually. So now we actually have time for questions and even more discussion on the panel if we'd like. So I will start. We still have a little bit more than 10 minutes. So well done, panelists. So I'd like to open it up to the audience for questions, if you have any. If not, then we can have some more discussion on the panel.
You can just pass it right over to Harvey. Oh, and we have power.
Lars, you reminded me. So now that you're operating ANA 300 together, and we discussed earlier the expansion of scientific traffic, what are the plans for the evolution of ANA, similar larger infrastructures? And what are you seeing in terms of the cost evolution looking forward to the next few years?
I think that depends a lot on the geography, right? If we're talking the North Atlantic, we're currently looking at 800 to 900 gigs of RNE capacity installed between partners that now are good at sharing, are doing mutual backup for each other, and I think the price curve also is pretty good. So I think we're safely ahead of the requirements curve for traffic there, and I think we'll be for some time. In other regions, I'm not that familiar with the Trans-Pacific, but it looks fairly good. What I know is that when we're talking Europe, Asia, where we're seeing dramatic increases in traffic, we're not seeing the similar dramatic drops in cost. But we are entering similar models now where we are working with SurfNet, with Xiang, with Singaren, with a couple of Japanese networks and so on, and on it in trying to together buy a system of 200 or 300 gig links between Europe and Asia, and I think that will drive down the cost there as well. So we're not quite ahead of the curve there, but I think we will be in 2 years' time.
Other questions? We have one later.
There'll be a question over there. Right?
Lars, I have also a question for you. Regarding your monitoring the ingress traffic, like on border traffic, have you been looking more holistic on that type of traffic in a context of CDN peers versus CDN local caches like Akamai or Google, YouTube and stuff like this? Just because this huge amount of traffic can hit your network if some of the local caches are down.
Yeah, that's one of the reasons we more and more are interested in NetFlow and flow analytics in general, because we need to understand the behavior of these things where we are seeing the same traffic from multiple sources, and some of them being caches inside, some of them being in Europe, some of them being in Asia, some of them being in different locations in the US. And we can do a lot of traffic engineering or do a lot of partnering with these people to make sure we get the traffic in the right places. But we need to understand the flow patterns.
But it also needs to have information where are those caches located, which is sometimes really hard to get.
Yeah, that's an ongoing discussion with some of these people to make them tell us what they have. Some of them are quite open to that because it also is beneficial to their networking. Google is better, Facebook not so good, but you know, it's anywhere in between.
Other questions? Okay, while you're thinking of them, then we still have a few more minutes, and so I was going to ask the panelists for all of the different work and projects that all of you are working on in this field. Do you have a particular ask or a charge for this community, the NRP community, and how they may be able to help your efforts or to add to your efforts to make it more valuable for the wider community?
Share your monitoring data. If you've got perf sonar nodes, have them open for testing broadly. If you've got to have some privately, we understand, but try to have key points where you've got nodes we can test against. If somebody says, hey, I'd like to, look at some of this data, I'd like to coordinate this with you, really think about it. Don't just knee jerk, oh no, you can't have that, because perf sonar data is open right now, pretty much. SNMP data is almost every archive of that in the US is open. Really think about sharing data, because I think that's really fundamental for us to be able to understand what's going on in the networks. And keep in mind, we're not doing the networks just to have big shiny networks. We're doing the networks to support science. If you want to support science, we got to see what's going on. That's my thought. Good luck.
Anyone else have anything else to add?
I'm really excited about where everything is going regarding the federation of Kubernetes clusters. And once we're there, I think it will be much easier to share data in a standard way and to share the measurements data, because it will be all interoperable. And so I guess we're going in the right direction, and I see a bright future for this data sharing.
Thank you.
I don't think I'm the right person to answer the question, but if I have to answer this question, actually we have deployed Persona and some Kubernetes environment in our network, so we have some similar experience as like the PRP and NRP communities. So we hope to share our experience in the near future.
I can just add that I think some of us already had yesterday a rooftop bar discussion, but maybe we should bring it up again in a more sober moment here. I think we are at a moment where there are quite some interest in the community, and there are good opportunities for us to look at smarter ways to analyze flow data. I'm not thinking about sharing flow information. I'm thinking about the tools we can use, the learning, maybe machine learning, maybe things like Elasticsearch, all kinds of other things, new things we can do in ways we analyze flow data. And I think there is an opportunity for some of us who are working on this to come together and share experiences and maybe develop some things together. I know there are big commercial tools out there, but I think we have an opportunity to try different approaches together.
Thank you. Any other questions from the audience? One last question for you is, do you, because I know that all of you may not be in the same place at the same time, do you have any questions for each other about the projects that you just presented? What? No? You may still be thinking of them. We have a few minutes. So, and again, I know that this was a kind of condensed project. Sorry, do you have a question? Oh, okay. And so I encourage you all to think about what you've just heard in the projects that they're working on and maybe how you might be able to help with that. And then talk with them on the next break. I know that we'll move on. But with that, I want to thank very much our panelists for all the work you're doing, and also for being on the panel and being so prompt with your presentations. Thank you.